Okay, what'd you do?
Volleyball practice.
You did what? Sounds like fun. Great. That happens every day in high school.
I was going for it, but not really. Like it was already twisted and she stuck it. Really? What are those? I know. But Michelle said like don't actually have them to do like support. So like Michelle put a little pressure on my foot. But she said she's kind of like used to have support, you know. I'm not actually here for like, so I'll run it. It's really sick right now. I'm down there. I don't know how that was. It was huge last night. I know. I feel so bad.
That easy. You got water all over yourself.
But it was huge last night. Like, it really hurt my nose. He did practice too tight. I hope Joe gets here soon.
Probably.
I'm coming down. You are?
So it's going to be easy.
It's usually in this spot. Okay. Now we can do this.
No,
Wait for me then. Because I'm in.
I think it's
Or
missing
whatever.
Oh, I can't find
They're
it.
third.
Here.
Okay. I'll just wait, yeah.
Why would people know?
Okay, what is it?
Spell everyone off, right? Alright, today we're just doing some notes. That's it. Very easy, very nice, pretty seamless today. We're doing algebra stuff today, which is kind of back to your grounds of what you had last year. So that's good. Now, the problem is what we have to do with it. So that's what we're going to talk about today. So we have a couple different topics. So have your notes out. We'll talk about it here in a second. Let me pop it up on the actual marker board here in a second, and we'll see how well you do. What's the date today? Okay, today, what we're doing here, what we're going to be doing is we're going to be doing some algebra proofs. So, like simplifying algebra problems, which is back to like the days that you did it long time ago. So, like for instance, let me give you an example here. Something like this. Do you think you can simplify that? Okay. PEMDAS, right? So what's the answer for that problem? 13. Okay, it's 13, not 25. Okay, because the PEMDAS, right? PEMDAS says you have to follow this order of operations when you do algebra problems, right? If it's this type of problem, right? So you see if there's any parentheses, which there's not. See if there's any exponents, which there's not, and you have to multiply or divide. These two go together. So that's why you multiply first, and that gives you 10. Then what you can do is after there's all the multiplying and dividing is done, then you can do adding and subtracting. So that's why you get. Does that make sense? Now, what type of problem is that called, though? There's two types. There's expressions or equations. Which one is it? What do you think? An expression. The reason why. No equal sign. Agreed? Okay. Even if this thing had a variable, you don't actually solve it. Well, all we're doing is we're evaluating it. So it could be something like this. Be a problem like that. And same exact idea. You can only go so far to simplify it. So I would look for any parentheses, there's not. I look for any exponents, there's not. And I want to multiply or divide it. So I can multiply these. So that is what? 8x. Can I go any further? No. Don't make that silly mistake where you tell me that's 11x. Or you tell me this weird situation that, I don't know why, people look at that problem and go, oh, okay, so we have 3 equals 8x, and then you divide by 8, and this goes away, and your answer is this. What are you doing? I don't know where this is coming from, that's not maybe that one, right? There's no equal sign. Don't magically throw one in there and then try to solve it, right? You don't do that. There's nothing there. So you can only go so far on that problem. Okay, now, those are fine and dandy. Most people don't make mistakes on those unless it's an incredibly difficult looking problem. And we'll look at one of those later. The one that people do make mistakes on is this situation. Believe it or not, people do make mistakes on that problem. I don't know how it's possible, but some people, they just look at that problem and they don't know the process for it. Because it's different, right? It's a different problem than this. Okay? Because that's an equation, it has an equal sign. When you do equations, you don't do PEMDAS, which is hard to believe. You actually do the exact opposite of it, which is called SADMAT. Right? It's literally PEMDAS backwards. It's called inverse operations. You go through the order of operations backwards in inverse order, reverse order. So what you're looking at this problem is you're going to add and subtract first. Either one, doesn't matter. Then after you're done with that, then you multiply, divide, and if there's any exponents or parentheses, you do those last. So on that problem, what's your first step? Subtract 3. Because this is what it's telling you. You need to add and subtract numbers first. So you subtract 3. This is how most people see it. So you subtract 3. Right? So the 3s would go, and you go up to 5x equals 10. Now what? Yeah, because you're doing multiplying or division, whatever one comes first. So you're doing what? You're getting rid of that multiplying by 5, so you're going to divide by it. And so what would your answer be? 2. That's how you do it. Right? That's what most people see. That's what we're doing today. Those types of problems. Okay? Does that make sense? Okay. So now, I always like to give this one problem to start with, just to see how you can do it. Okay? So this is this little problem for you. I like to put it in your notes. See if you can simplify this problem down and show all of your work. Okay? You with me on this? Okay. All right, here we go. So I'd like you to show all work on this problem. All you do, simplify it. There's no way we can evaluate it, so we're just going to simplify that problem down. Now, what type of problem is that? It's distributed. I agree with that. That's one of the properties we're going to talk about today. But is it an equation or expression? Expression. So you should know the order that you need to go. I want to see what you get. Show all work if you can. Okay, so here's my question. All right, what do we get for a final like simplified version of that? What do you eventually come up with? Bailey, what do you think?
17x plus 41.
Okay, agree or disagree? Agree. Okay. Now, how many steps? Like how many lines of work? If you look down your lines of work, how many lines of work did it take you to do that? Some people probably did one, two. How many like total? Like I want to hear like the smallest number, 2. What's the biggest number? How many steps did somebody take? Like, is it more than 2? Is it 2? Okay. What if I told you to do that problem correctly according to geometry? It takes 7 lines to do that problem. It takes 7 lines of work to actually simplify that line. Okay. It's to actually justify the answer. The answer you guys came up with like in 3 seconds, right? Because I only gave you less than 30 seconds. It takes 7 lines of work with 7 property names. And that's what I want to show you right now. Like what we're getting into. Now this is not to scare you. This is to show you the level that we need to be at maybe by next week. Does that make sense? Like somewhere where we're going to eventually get to. Okay, so let me show you this, because I want to throw you in the deep end so you can actually see what I'm doing here. First line, you actually said it right. It was distributive, right? So that's what most people do. They distribute with 3, they distribute with 5. And I'm betting all of you did this in like one little line in your head, and you just wrote down your answer. You just skipped like 3 properties. I'm doing it. So distribution, if you don't know, is literally the act of handing the 3 to everything, or handing the 5 to everything. But it's not actually multiplying. That's the crazy part. So it's actually doing this. It's putting the 3 next to the 4x and putting the 3 next to the 2. And same thing with the 5. Putting the 5 next to the x and putting the 5 next to the 7. That is distribution. Make sense? Like, most people know it, but they just do it in their head. They just, like, real quick, like, from algebra class, you just, like, blitz through. Now, the second property is a little bit goofy. I need to throw in a number in front of this x. And I'll explain why here in a minute. But what number is in front of this x thing? A 1. I need to throw that in there. Okay, so that property, by actually throwing that 1 in there, I would actually probably need to write a whole new line of work here. In fact, I'm going to do that. So I'm going to throw that 1 in this next line. Because that is a completely different property than what I just previously showed. Now, if you're doing all the same property like I did, you can do it all at once. But since that is a new property, I need it to make its own line. That is called a multiplicative identity. Property in algebra. When you multiply by the number 1, 1 doesn't change anything. It's not identity. Identities don't change anything. Okay, so now that I've introduced the 1, the reason why I'm doing this is because technically when you actually distribute, you don't actually distribute the 3 to an x or the 5 to the x. You're actually taking the 3 or the 5 times the number in front of it. That's what we're doing. So that's why when you distribute, you just put it out front. This is actually distribution right here. It's not the simple fact of what you guys did where you wrote down like 12x, 6. That's a different property. So distribution is where you hand it out. Now, the next step is the weird one. This is the one that most people tend to forget. You actually put the parentheses around the 3 and the 4, because right now they are actually separated. They're not touching each other. And then I put the parentheses around the 3 and the 2. And I put the parentheses around the 5 and the 1. And the parentheses around the 5 and the 7. I know that is like super tedious, but that is what you're doing, right? And that is called the associative property. The associative property is when you're associating. You're like grouping things up. It's a grouping symbol. You're associating digits with each other, not variables. And then, so right now I'm already at what, line 3? Line 4 is a line that you probably all did the very first step of your problem. The next line is when you actually multiply 3 times 4. And 3 times 2. And this one, I actually have to skip. That is a different property. And 5 times 7. 35. That is substitution. You're probably wondering, why did I skip the 5 times 1? 5 times 1 is a different property. We've already written what that property is up here. Anytime you multiply by the number 1, that is different than substitution, because multiplying by 1 doesn't actually change your variable. Like, doesn't change the answer. Like, before, 5 times 7, right? I magically changed that to a new number. Do you agree that I never had, above this point, above the blue line, I never had 35 on the board before? Agreed? Okay, so when you create a new number, that's when you do substitution. It's a brand new number. It was never on the board before. Like the number 6 was not on the board before, so that's a brand new number. That's substitution. And 12, same thing. But this number was on the board before. What's 5 times 1? 5. That was on the board previously, because it never changed. When you multiply by the number 1, it doesn't change your answer. So it gets its own property name. So that is the number 5. At this point, turn on some. That is a multiplicative identity. Now, I'm going to stop right there. I've already done what? 5 lines of work. Right? 5 lines. You probably got there, right there in that line, in 1 step. Agreed? It took 5 lines of work to get me to the 1 line you did. Now, don't get me wrong. You did correct mathematics. But what you didn't do is show me all your work, which is different than what I need this. That's work. That's what I'm showing you is justifying why answers turn out the way they do. Every line of work. This is what they're actually supposed to teach you in Algebra 1. They're actually supposed to teach you in pre-algebra. And what they're supposed to teach you in 7th, 8th grade math, 6th grade math, 4th grade math. Now, honest raise of hands. How many people have ever seen that before? So far, not even done. I've watched 3, 4 lines of work. Raise your hand if you have seen it before. Yeah. You're probably wondering, well, why didn't they teach us that before? If that's the real way to do it. Because how many people, honestly, in 5th or 6th grade could handle that? Nobody could handle that. In fact, it'd probably make you run out of the room and never want to go back to math class. It probably makes you want to do that right now. But it's right now you're at that moment where developmentally, like mathematically, you are ready to see this for the first time. Because you've got all these skills up to this point. Because obviously you guys already know how to go from here to like 1 second. But now we got to fill in the gaps, like the real stuff behind it. So you understand, you can justify. That's what geometry is. It's justifying why things work. That's what we do. This is why algebra works, because of all those properties. Now, I'm not even done yet. I still got to keep going. In fact, I'm going to put that over here and finish out. That's where we at, right? Let me read that line. 12x
Plus 6 plus 5x and plus 3.
Okay, so we've got to this point. Alright, so we're ready. Okay, that's the green line. Alright, so at this point I need to go further. Now to go further, I need to group things together. So I need to move the x's next to each other. So I'm going to move the 12x and the 5x next to each other, and I'm going to move that 6 and the 35 next to each other. What I just did there, that is called commutative property. Commutative property. Commutative property is when you move items around. The root word there is to commute. Commuting is to move. Like if you commute to work, you actually move to work. You group and move. That's what we're doing. We're grouping things together by moving them around. It's not actually doing it. We're just rearranging stuff. Because technically, the 6 and the 35 are not even next to each other. So you have to get them together. Okay, it's like how I like the way that I think of this. It's like imagine you went to the store and you're going to buy something, but you left your money at home. You can't buy it. You can't technically add these because they're not even next to each other. They're not in the same pocket. So what you have to do is you have to move them next to each other. So now you went to the store and you have your money in your pocket. They're next to each other. So now you can actually purchase something. Right? That's how I think of it. You have to move them around. Okay. So now at this point, so that's what we did. Now I can actually try to add these x's, but you don't just make 17 of them. You have to get the numbers next to each other because it's still the same issue. You know, you're at the store, but you left your money at home because they're not even next to each other. you have to move the 12 and 5 so that they're physically touching. What I'm doing here, this is distribution backwards. It's actually called reverse distribution or factoring. When you're taking out the x on both of them and putting it outside, and it goes in the back because that's where the x's are found. Because they both have the same x, so it pulls it out back. So that is distribution, right? And the 6 and the 35 have not changed. Distribution or reverse distribution, if you want to think of that. Or factoring. If you've ever learned how to factor in algebra class, and what few of you have. Now, I have one line of work left. So it is going to take 8 lines of work. 12 plus 5. 6 plus 35.
41.
And that's what we had, right?
Yeah.
And that is substitution. The reason why that's substitution, we were creating new numbers by doing simple arithmetic. And we're done. We took 8 lines of work for something that took you 2 lines. That's justification. What you're looking at right there is a 2-column proof, statement reason proof, why algebra works. Why do we get the certain answer we do? You actually have. That's the type of stuff I want us to be able to do. By, middle of next week, where we start doing this more and more. Right now, we're not there. What I'm worried about right now is, can you even get to the right answer in the first place? That's what I worry about. Because some people, they do struggle with that. They do simple errors, especially when there's negative signs and stuff. I want us at least to get from the start to the right answer. But then once we get there, now we can start filling in the little gaps. Now, obviously, this is throwing you into the deep end. No one's going to know how to do this after just watching them do that. That's ridiculous. So what we're going to learn is we're going to learn little pieces. Like, how do you distribute correctly? And we'll look at how to do that problem. How can you do things where you add variables together? We'll do that separately. And once we learn these little pieces, one at a time, we're going to mix it all together, and then you should be able to handle this, where you can just kind of do it. Where you just kind of, oh yeah, this is the process. It's this thing every single time. This is that idea of like doing law of detachment and law of syllogism, right? Law of detachment is where you memorize like a process for how I do it on the board, and then you detach it and you apply it to a new problem. Like this right here, what you're looking at right here, this is how you add variables together every single time. Like when you add variables on a problem. You need to move them together, you distribute them, you add them. Like it's 4 lines of work every single time. That's a law of detachment. You're going to take that and you're going to use that every single problem that you do. Or when you distribute, you do like 3 lines of work. You distribute the number to everything, you do associative by moving parentheses around, and then you substitute those answers. Like that, it's always 3 lines. And we had the extra line, that stupid multiplicative identity in there. The variable you didn't have a number in front of it. Okay, that's the things we're going to learn over and over and over. Okay. Are you well and scared now? What we're going to have to do at some point. Okay. Let's jump out of that. Let's go to a different problem. I like playing defense. So let's try another problem. Let's go. Let's go to this problem. I would like you, right now, if you can, to solve this problem out. Don't worry about property names or anything like that, because obviously you don't know any yet. But I'd like you to simplify this problem down and show your work, if you can. What? No. Just simplify it how you would. Don't think about any lines. Just simplify it. Get me to the right answer. That's all I care about. Don't worry about lines or anything like that. Just use normal algebra like you always would. Don't think about lines. Don't overthink it. show of fingers, what is your answer? 3, right? 3? Everyone get 3? Okay, 3. All right, that's your correct answer. So that's what you should be getting. So if you didn't get 3, not 3, but okay, we should be at 3. All right, now, how many lines of work did it actually take you to get to 3? I'm betting on maybe 2, maybe. Sure, showing work. 2.
I didn't even know how to show my work, so.
Okay, there's. Okay. All right, did you get to 3?
Yeah.
Okay, we're good. All right, so it takes 8 lines of work to do this problem. Legitimately 8 lines of work to do this simple algebra that you take for granted in like algebra classes. Okay, that's what we need to get to every single time. Anytime you add another part to this problem, like another variable or something else, it will take 4 more lines of work every single time. It takes 4 lines to get rid of a single number. So the first thing that most people probably did, you want to get rid of the number 1, correct? It takes 4 lines of work to get rid of that number 1. 4 proper names to get rid of it. To get rid of the number 3 in front of the x, which you guys did in like 1 step, right? It takes 4 lines of work to get rid of that number. Every single number takes 4 lines of work. So that's what we're going to learn over today, tomorrow, Wednesday, or today, Thursday, Friday. That type of thing. That we're good at. Right? Okay, so let's try this out. So on this problem, this is the correct way you're supposed to do it. So if you want to write this down, first step, most people do it right. They want to add 1 to both sides. You are doing correct mathematics when you do that. Now, this, what you're looking at right there, where I added 1 to both sides, not actually physically adding it yet, just putting the +1 on both sides of that line. That is called the additive property of equality. Really long name. Now, why it's a property of equality? Would you agree that this original problem has an equation, right? It's an equation, it has an equal sign. If it has an equal sign, like this problem, we use properties of equality, not the field properties of equality. That's what it is. Okay, that is the first line right there, what you're looking at. I have done no math yet. I'm just physically writing +1 to +1 on both sides of the equal sign. The next line of work is actually a bunch of stuff here. Okay, so on this side, this is what most people do automatically, right? You do 8 plus 1. Agreed? 8 plus 1 is 9. That's substituting. Substitution, right? Doing 8 plus 1. That number was not on the board originally. I added a 1, it changed it to a new number. It wasn't previously written, so it's substituted. Now notice, I skipped the -1 and +1. I skipped that part. That was a different number, agreed? It was like it's not the same mathematics. And most people are like, well, isn't it just substituting? You're creating a new number. No, because the number I'm going to create is very special. Okay? So the number I'm going to create, what do you get when you go -1 plus 1? 0. You actually have to physically write that. 3x plus 0. That property, by taking 2 numbers, adding them, or subtracting them together to make 0, is called the property of opposites. The property of opposites is when you add or subtract things and they make the number 0. They literally cancel each other out. But you still have to put 0. 0 is still a digit. You have to write it down. It's not substituting. Substituting is doing any other number, adding, subtracting, multiplying, dividing, creating random digits, but not creating 0 and not multiplying by the number 1. Those are special. Because the next line, when I actually add 0 to 3x, what's 3x plus 0? 3x, right? That's an additive identity. Because the 3x is already previously written, so it's an identity, right? It didn't change my problem by adding a 0 to something. That is the additive identity. Okay, so all it took me, if you look at this, it took me 4 lines of work here. You can see it. And what did I just get rid of? I got rid of that negative 1 part. That's it. I'm down to 3x minus 9, or 3x equals 9. That's it. That's what I'm at now. 4 lines of work. The next 4 lines of work are almost the exact same properties again. Next 4, because I need to get rid of the number 3. But the only difference will be subtleties in the name. So instead of additive property, what do you think my next property is going to be? What? Say it again. Division property equality. Because I'm going to need to divide both sides by 3, and so it'll have 4 properties. You can see this. So I'm going to start this. I'm going to do the same thing. So I'm going to divide both sides by 3. That's the division property of equality. Some books refer to it as the quotient property. So division property of equality. I call it division. This in here. Most people don't realize quotient means to divide. They always forget that. It's the result of dividing. Okay. So it's just me physically writing divide by 3, divide by 3. Most people like to do that in their head. Right? So now, on the one side, what's 9 divided by 3? 3, right? So this just makes the number 3. All I did there was substitute. Substitution, because I did 9 divided by 3, that created a new number, so that was just simple arithmetic. On the other side, though, 3 divided by 3, that is a special case. That is a property, kind of like the property of opposites. We're creating something special because you'll see what's going to happen here in a minute. Anytime you create the number 0 or you create the number 1 by using like multiplying or dividing or something like that. So 3 divided by 3 is the number 1, right? Does create the number 1. That is called a reciprocal. Probably seen the word reciprocal now in class. You like to divide by fractions, right? Reciprocal is any time you divide by something and it makes the number 1. That's a reciprocal. So it's kind of like the property of opposites. Because it's going to cancel stuff out. That's what it's going to do. Because the 3's basically go away. And the last line is taking the 1 off. So 1 times x is just x. And the reason I'm allowed to do that is because that is a multiplicative identity. I'm multiplying by the number 1 and it doesn't change anything. Anytime you add or multiply by something and it doesn't change, that's an identity. So you just have to tell me what you did. Oh, I multiplied, so that's a multiplicative identity. Oh, I added 0. That's an additive identity because it didn't change the problem. So, how many lines of work did it take me to get rid of the number 3? 4 lines. You always start with the property of equality. You use some type of substitution. You do some type of property of opposite or reciprocal, and then you will always do usually an identity last. It's the way it works. It's every single time. It's the same 4 steps. Equality, some type of substitution, some type of property of opposites or reciprocal, and then the identity last. 4 lines, 4 lines, 4 lines, every time. So if I throw another number in there, boom, 4 lines, exactly every single time. That's the type of work that we eventually in this class need to show. Now, we're going to start slow, because obviously that is wicked looking. Like how many properties there are, especially like you've never had to do that before, showing that level of work. So what we're going to start with is just real basic stuff, like real basic, and then we'll start filling the gap with all these different property names. Okay, so that's what I was talking about. I was talking about these properties of equality versus the field properties. There's a difference in property names. So I want to show you those right now, and then I'll show you kind of where I want you to be today. So we'll do maybe one more example to show you, and then maybe Thursday we'll pick up and we'll do a couple more. Does that make sense? So you can kind of see like where I want you to be by the end of the week. Okay, not here yet. This is like next week. You need to be here. Right now we're just going to do simple stuff. Okay, and I'll kind of explain how the book goes. All right, so let me give you the list of properties. And eventually this list will be on my website, so if you go to the website and check kind of what you missed and stuff, if you don't know my website address, it's over there. I always have it up. You just go to geometry and you can check out the lessons we do every day. Videos, whatnot. Okay. So the property that I want to discuss here. Well, we'll get to these field properties here in a minute. The properties of equality, just so you know, so you have a list here. And I'll try to post this list tonight. Okay, the list. There's the additive property of equality. So add prop of equality, right? That's when you magically add things to both sides of the equation. So, for instance, if I had the number 5 equals 5, would you agree that that equation is true?
May I have your attention, please? Joe from Athletico is here. If there are any freshmen or sophomores that need to see him, please go down to the locker room area at this time.
Okay. So do you agree 5 is equal to 5? Okay. So, what the additive property of equality says, you can make up any number you want. Make up any number, but add to both sides. Okay? So, create numbers. Throw out a number right now. 3, 7. Okay, it doesn't matter. So I'll say 37. We'll mix them together. Right? 37. You can magically add that to both sides. What you're seeing here, just me physically writing plus 37, plus 37. That's the additive property of equality. It's not going further. It's just the simple fact that I showed that I can add 37 to both sides. Why that's property of equality? Obviously, my problem starts as an equation. Agreed? And why you have to do this, why you have to physically add to both sides, it's because it keeps the equation balanced. You always hear that a lot in algebra class, right? You have to keep equations balanced. You have to do the same thing to both sides of the equal sign. That's why I'm showing plus 37, plus 37. Agreed? So it'd be like a situation like this. So imagine I cut this room in half. So you guys are one half and you guys are the other half. And this half of the room, you guys get pizzas today. You can eat pizza all day, but you guys don't. Would that be fair? No, you guys would be pissed as hell if that happened, right? So it'd be like, it's not a balanced equation. I added pizzas over here, no pizza over here, it's not balanced, and I'd get riots. All right, so, but that's the idea, right? You gotta keep the same equation on both sides. That's an additive property of equality. Now, the numbers will turn out to be the same if I kept going. Those will be different property names. Now, number 2, the second property of equality is the subtraction property of equality. I've also heard it referred to as the difference in property of equality. The differential property of equality. The subtraction property of equality. And this is the same idea. I can magically subtract numbers from both sides, as long as you do it to both. So it's a situation where, like, let's say I created the number 1, right? I can magically just subtract 1 from both sides. You're allowed to do that. It makes up new numbers, but it's balanced. It's that idea, like, if I were to go around the room and take everyone's math book away, everyone's math book, that's a balance. It's equal. It wouldn't be fair if I took half of your math books and you guys could keep yours. It wouldn't be fair. Some people would do homework, some people couldn't. That's the idea. So subtraction property of equality. You probably know where I stand. But all right, number 3. The next one is the multiplicative. Multiplicative property of equality. This is where you can magically multiply by numbers on both sides, but not by 1. You can't multiply by 1. That's a different property. It's just make up any random number other than the number 1. 7. Okay. We can multiply both sides by 7. It's me physically writing times 7 on both sides. That's the multiplicative property. Now, most people never see that little time symbol. I mean, that's goofy. No one really sees that. This is how you normally write, like, multiplying by 7. You write it with a little dot. And you do it like this. The big idea here is that when you multiply by 7, you have to do it to the entire side. The entire other side. That's what some people tend to forget. Adding's easy. Just tack it back, right? Plus whatever. But when you multiply, everything has to be multiplied by 7. And the last one is the division property, or quotient. We just did this one last week. Quotient or division property equality. These are the ones that most people are very, very familiar with. That, I can magically divide by both sides. So, like, over here I can divide both sides by the number 2. Divided by 2, divided by 2. But now, most people don't see it like this. How would they show dividing by 2s? Instead of using this little quotient. Yeah, like the little fraction, right? That's how you show division. Divide by 2, divide by 2. That's how you write it. You have to divide the entire side by 2. These four properties are the ones that you learn in Algebra 1. You do. You learn them, but you do it in like one set. Like, oh, divide both sides by 2. There's your answer. That's it. Okay, but you don't realize, like, when you do these, this is what you see. That's it. That's all the property is. It's just physically writing divide by 2, divide by 2. That's it. That's all it is. It's not going further. Going further, like to get what this answer is, to get what that answer is, that's these properties. It's the field properties. Those go further. Those are like substitution and multiplicative identity and commutative property and distribution property and property of opposites. Those are all the different property names we're going to start learning. Those are going further. These properties of equality, just set it up so that you can solve it. That's a setup of that problem. I can go further later. Okay, now, these are the ones that most people know. They have no problem with these usually, other than going further and knowing all those other properties. There is a couple other properties you need to know. A couple other ones. Number 5. This first one is a kind of goofy one. It is called the reflexive property of equality. Reflexive property of equality. Okay, reflexive property of equality is when you set up an equation and you set the things equal to themselves, like this. When I first started this problem, you guys agreed that is a balanced equation. Agreed? What you're seeing there, right there on that board, that is a reflexive property. The left and right side are exactly the same